Hello, everyone. This is probably the best time to kind of transition and talk about a quick update on what we've been up to at IADS and some of the things we found and some of the definitions that got shaped. Primarily, this is all intended to collect your feedback, your thoughts, your ideas, your suggestions, etc. So with that, I will share with you a presentation. I'm hoping that it's only a 20-minute presentation. I want to leave the rest of the time for questions and for discussion. Our quick update here on IADS, and we'll share this presentation with you, of course, and we'll give you all our contact information in case you get ideas and you want to participate. The question starts with, do we need these standards, right? We know certain fields that we consider critical, like pilots, surgeons, lawyers, even engineers in many fields, require qualification, certification, and in fact, repeated recertification to make sure the skills are up to date and they meet a certain standard. You know, should data scientists be exempted of this? Of course, we believe not. We actually think, especially now with the super digitization of our world, thanks to the reaction to the COVID disease, the importance of data and the importance of extracting information from data and using it to understand and guide where organizations go, how organizations react, to understand the world, to understand customers, the competitive landscape, what is happening with customers, why are they leaving if they're leaving, are they receiving, is the services we promised them, is the product working, is it not working, if not where? All of that has become very dependent on data. All of that has become dependent on the ability to gather that data, manage it, then use it to guide the business. So we think in the future, if you are not basically tuning into your data, you're probably, your chances of survival are probably a lot less than you were able to get away with in the past. Also, we know over the past decade that data science has been a global hot topic. All the way from, you know, big media outlets talking about it, the Harvard Business Review calling it the sexiest job of the 21st century, Glassdoor showing data scientists as the top job in America for 2016, 17, 18, and 19. I'm sure 20 will prove to be a continuation of this pattern, especially World Economic Forum, etc. So no need to go through that. It's a hot area of attention. We also, you know, have worked on getting roughly estimates of numbers of data scientists in the world. We think it's at least 3 million. One estimate we have is basically participants or members in Kaggle, right? And you typically don't have any reason to be on Kaggle unless you're participating in some or care about some competition involving analysis and especially data science and machine learning. Comparisons in terms of 2018 to 2020, what percent of the organization is data scientists? Not surprisingly, startups, you know, have a higher percentage. But if you look across the board in terms of the size, there's been growth in terms of how many data scientists are employed by a company, or how many people in a company work on data science. Also, if you look at it from kind of the challenging to find people in the rapidly evolving fields, right? So projected growth versus the hardness to fulfill the role, kind of this disruptor space, if you notice, is highly concentrated around things like analytics, data engineering, data science, business intelligence, etc. Right? So it's also hot. These areas are very, very relevant to the areas of biggest growth as well as difficulty to fulfill, right? And the two, of course, are not uncorrelated. Also, and I've shared this slide before, if you look at kind of job holders holding the same title in the same company, this is an example from Facebook, right? and you look at their backgrounds, you find that the candidates come from very different educational backgrounds. You wouldn't guess a priori that these would be all fulfilling the same title role, right? So that shows you variance inside an organization. And of course, if you look across organizations, the variance is even bigger and bigger, right? As you look at their skills, their training, what did they study in school, what have they been working on, etc. So our initiative, IADSS, for the analytics and data science standards, uh, aims to support kind of the ecosystem by defining these standards, right? And this looks at job titles and roles. We look at knowledge and skills requirements, and we look at assessments and measurements. How do we evaluate all this once we agree on the standards? We have an advisory board that many of you are familiar with. They've been very active in kind of helping us both get the word out and get feedback and give suggestions on what to look for. We've done a research study. A second one is coming up very soon that delves deeper into details of the data. But the first one, and I'll talk about it today, targets kind of an overview of the areas of knowledge we expect the data scientists to have. And we'll talk a little bit about the response to the surveys and other research. We've also been very active reaching out online and in conferences and in meetups, etc. And I've listed a sampling of them over here to show you how active we've been in kind of getting the word out there and getting attention. And the community has tuned in. I'll point you to a longer report here that we co-authored around a knowledge framework for professional standards, right? This is around kind of defining the basics. What is the body knowledge you have to know? And it's published in the Harvard Business Science Review, Harvard Data Science Review. We're working now on the second publication, which will include a lot more detail on our research from the interviews and the surveys that we've conducted. There's definitely unmet demand, and we have all sorts of statistics around how much there is in demand and how much there is in supply. We also have very reliable estimates of the gap between demand and supply, which is actually pretty scary. Worldwide, it's about 700,000 positions that we don't even have people qualified to fulfill in the market. There's a huge growth, of course, in training offerings, and there's little consistency there. And this is why the focus of this workshop really is, what should we do about training? How do we make training more useful, more consistent? How do we, get the word out for the trainers, for the schools, whether you're degree granting or not, on what you need to train these data scientists on? And then how do we make sure this meets the need from employers and people who want to hire data scientists for their projects? How do we create trainees who are useful? Let's start out. We did some work on researching kind of the brief history of data science, and you're welcome to see it in the Harvard Data Science Review paper. But we also looked at prior definitions, right? And people have been defining this, like, way back in 1974, Peter Nauer said, basically talked about the science of dealing with data, right? In 2012 is when the term data scientist got coined. And you see kind of the high variance in these definitions of what we mean by data scientists. So, of course, just to contribute to this, actually in hopes of getting a more useful kind of consensus, we came up with our own definition of data science. And we say it's about using data to achieve specified goals by designing or applying computational methods for inference or prediction. And we have expansions of each term. What do we mean by data? And there we say it's structured and unstructured, for example. What do we need by achieving specified goals? This is about exploration, discovery, decision-making, prediction, optimization, etc. Designing or applying, what we mean by that, right? And also the fact that there's an emphasis here on computational methods, either directly doing the work or aiding humans to do most of the work to help them reach inferences that are primarily done by machines, by the way. They don't have to be done by humans, but they could be. Or prediction, where the task is not really about discovering knowledge or understanding it, but about predicting some variable. How do I best use the data to predict it? So This is our working definition. We readily admit it's not going to be the last word here. And we hope to get revisions over time. And we hope that the revisions kind of make it narrower, better defined, and more useful to people who need to answer the question, what is data science? We've also defined data science knowledge framework that includes multiple areas in data science and analytics. So sciences and math, scientific method, mathematics, computer science, operations research, etc. And also it talks about tools and programming and technology to support, but it also goes deeper, right? So it actually goes down to the details of what you should know or what we expect you to know within each of these subfields and how much you need to know about it, etc. Now, this is again, work in progress. It will get refined over time. It will get expanded over time, but it's a start. It's a start of a framework of how do we start defining these standards, right? What do we expect a data scientist to know? We collected in-depth data from over 30 plus in-person live interviews with executives and in data science, so big managers of big teams, plus 500 plus surveys filled from a lot of companies, big and small. And we addressed the survey to data scientists, data analysts, BI analysts and specialists, data engineers, big data engineers, as well as professionals in those managerial roles. So we've also done an extensive analysis of 2,700 plus LinkedIn professional profiles and compared them against job postings, etc. We heard earlier about the unicorn data scientists, and we believe that it's not about the unicorn, it's about a team. And Tom Davenport in his article did an excellent exposition of how to think about this and what is the problem with it. In his paper, I highly encourage you to go read it on the Harvard Data Science Review called Beyond the Unicorns. So the problem today is that many members of these teams that basically do data science are called data scientists, and this creates confusion. And there are distinct roles within those teams that shouldn't all be called data scientists. The problem of finding the unicorns is, of course, it's near impossible, if not very difficult at best. And it leads to further disenchantment, right? If you're looking for that unicorn, you don't find them, you say in frustration, well, I don't need to build this data science capability. I'm never gonna get there, or I can't compete with the big guys, or whatever. So we need to kind of decompose this, factor it, and show that, no, it's actually possible to achieve this kind of unicorn target, but with the right mix of workers on a team. So the roles that emerged, right, from the framework and from the surveys is that, and this wasn't straightforward. The results are simple, and I'm glad they're simple, right? I want them to be simple, but it took us a long time to sort them out, right? So we landed at having these categories: data analyst, which includes both data analyst and BI analysts. We had BI separate, but actually in the end, we found arguments to actually group them together. Data engineer, which is including data engineers and big data engineers. In fact, we think big data engineer will kind of disappear over time, and it will be all subsumed under data engineer. And then data scientist, which is a distinct role from the two above roles. And this became very, very clear from the analysis, from the job postings, from the questionnaires, and from the private interviews. So basically, our first high-level category is these three roles. You may ask, what's the difference between data scientists versus data analysts? And I show you the different areas here ordered by the difference, right? So things that are more heavily weighted towards data science versus data analyst, right? So not surprisingly, machine learning, predictive modeling, etc., right? NLP rank much higher in the difference, weighted in favor of by the data scientist. And at the bottom are the things that are more heavily weighted by the data analysts. Not surprisingly, also reporting visualization tools, spreadsheets, etc., right? So in summary here, data analysts versus data scientists. Data scientists are not upgraded analysts. They are actually not unicorns. They are different than data analysts. They actually do development using enterprise databases and data warehouses. Analytical stores are much more important to them. ETL tools are a lot more important to them than the data analysts. Machine learning theory practice are rated much higher by data scientists, not surprisingly, as well as predictive analytics techniques, scripting languages, um, statistics. Data scientists also favor the data engineering tools, the tools used mostly by data engineers, much more than data analysts. Again, not surprisingly, they skew more towards kind of the programming side of the house. If you look at data scientist versus data engineer, another interesting comparison, how do these two differ? Actually, they are pretty different, right? Favored more, and again, these are ranked by the differences. So the stuff on top here is data scientists rated that much higher, machine learning, predictive modeling, statistics, etc. Whereas at the bottom, database, data warehouse, analytical data stores, customer resource, cluster resource managers on the cloud, especially ETL tools, etc., are much more favored by the data engineers. They think those are way more important for data scientists than data scientists believe they are more important for data science. So data engineering is distinct from data scientist role with clear skill requirements. Data science, they don't view big data stores and processing technology as critical to their job. Typically data scientists think they can do it all by just grabbing their own data file formats, a big cause of problems, by the way, and doing their own analysis in their own kind of build-it-yourself world. The development related to databases, data warehouses, ETLs, etc., are usually performed. That work is usually performed by data engineers, not by data scientists, because the data scientists may not know the technology details of how to make this stuff work. Data engineers favor proficiency in development tools and virtualization, containerizations. Data scientists don't think these are relevant. ML model deployment is becoming very relevant, much more relevant and increasing in relevance. And that's a sign that probably this whole ML engineering area would probably be just subsumed by data engineering. Other conclusions, besides the three roles, is that the list is kept concise because we want it to be kind of manageable and understandable quickly. Of course, we're going to subdivide it and make it more complex. You could further do distinctions based on things like seniority, right? So executives, for example, they prefer kind of general knowledge and practical skills. Uh, or it could be kind of also distinguished by based on line of work. So you can specialize in a certain area where besides knowing everything a data scientist needs to know, you need to know a lot more about the domain. So for example, biomedical data scientists, right? Or a data scientist working in healthcare, where they need to know a lot more about the domain to be effective. And a generic data scientist would be a lot useful in that area. Some future work we're working on now is kind of, can we find subtypes of data scientists in order to help with the training, with the preparation, with the assessment, etc. So can we divide them? And by the way, the data doesn't point to this yet, and this is why we need to collect more and delve deeper. Intuitively, in my thoughts, I think, for example, whether somebody is skewed more towards statistics versus databases versus algorithms, are they CSAI ML? Are they optimizations or operations research, visualization focus, etc.? These could be different types, we don't know yet, of data scientists. Level of expertise in core data scientists from junior, intermediate, senior, master. Depths of domain expertise required in addition to the core data science for you to be effective in these specialized jobs, right? Those are areas to think about for the future. By the way, the elusive unicorn does exist. It is not impossible. And in fact, we have a sub-community of data scientists that basically say, if you're not a unicorn, you're not a data scientist. And that's reflected here. And the kind of the members of this unicorn group, compared to everyone else, they really basically, if you notice, they consider almost everything more important or important. And that's the problem. It's very hard to find somebody who has this everything, but they do exist. They are not zero in the population. And we think actually, and I think Tom Davenport in his article and his presentation agrees that a more pragmatic approach to this is by replacing them with a team with the right mix of skills that can easily do as well as or even surpass the unicorns. Finally, I'll continuously remind you, we would love for you to engage with us, share expertise, be a part to help us build a diverse global community and support content development. So I've listed here the how and the what. We encourage you to reach out and kind of get involved, whether you're attending the workshop live or seeing a recording of it in the future or reading some of the papers. And here's my contact information and ways to contact IADSS, which is probably the most effective way to kind of get in this quickly. So with that, I'd like to end the presentation and move over to a live Q&A and discussion session. So let's move over to that.